So this lesson is all about the surface area of pyramids and cones. And so we're going to take, like we did with prisms and cylinders, build up the surface area formula and then just extend it into this related set of 3D figures being pyramids and cones. So before we get started with the actual surface area, I want to take a second to review the critical parts of a pyramid because we're going to need to remember what those names are in order to be able to talk about surface area. Now, every pyramid has two important things. It has a base, which is being outlined in purple, and it has an apex, which is being circled in blue. Now, the way that we know the base from the rest of the faces is that we can identify the apex and know that the base is directly across from the apex. Or we can say, what can we set the pyramid on so that it sits with the apex up in the air? And if we do that, or identify any shape that's not a triangle, we will always find the base of the pyramid. And so we need to know what faces the base, and we need to know where the apex is in order to be able to find the surface area of pyramids. Now, real quickly, just like prisms, pyramids are named for the shapes of their bases. On the left, we have a square pyramid because the base is a square. On the right, we have a pentagonal pyramid because the base is a pentagon. And in the center, we have a hexagonal or hexagonal pyramid because the base is a hexagon. The apex of each of these pyramids is across from the base. If we were sitting these pyramids on a surface, the square, the pentagon, and the hexagon would all be sitting on our tabletop or the ground or whatever it is that we decided to put them on. So I'm going to go ahead and turn the webcam on now so we can look at a collapsible pyramid just like we did a prism in the prism and cylinders video lesson. So here we have two good helpful models for pyramids. We have one which is our big familiar one that we have in class. The base is color-coded green so that we can tell where the base is. Not particularly helpful for surface area except to look at because we can't collapse this down and manipulate each of the faces here. But we can see that the base is in green as a square and the sides, the triangles, are all clear. The apex is across from the base. But when we really want to talk about surface area, we want to talk about one of these kind of pyramids so that we can collapse it down. Now, the difference between a pyramid and a prism, or one of the differences rather, because there are a number of them, is that a pyramid has only one base. A prism has two bases, a pyramid has only one. So when we find the area of the base, remembering that surface area is just the area of all of the faces that are involved with this 3D figure, we only need to take the area of the base once. The more interesting part is the area of each of these triangular lateral faces. Now we can take the area of one of these faces relatively easily because it's a triangle and we're familiar with the area of a triangle. We know that the area of a triangle is just a base times the height. Well, if we reattach this face back to the triangle, or back to the pyramid rather, we can see that the base of this particular triangular face is just the length of whatever side of the base it happens to be on, and the height is the distance from that base up to the apex along that face. Now, if we have something like a square pyramid, it's not that hard to find this triangle plus this triangle plus this triangle plus this triangle. But as we get into larger and larger pyramids, pentagonal, hexagonal, decagonal, etc., we would want to find an easier way of looking at it. And so it turns out, and we'll see this through an exploration tomorrow in class, that we can just take the perimeter of the base and multiply it by the height of one of the triangles to create a formula for the area of each of these lateral faces. Now we're not looking at the distance directly from the base up to the apex because that would drop straight from the apex down to the base. Rather, we're looking at the distance along the lateral edge from the base up to the apex. And that is not what we call the height of a pyramid. The height is the distance dropped from the apex down to the base. It's something that we call slant height. Now, for a prism, we talked about the bases plus the area of a lateral surface, and so that's what we're going to talk about with the pyramids too. So for any of these pyramids, one of the faces is the area of the base, so we just need one of those, the area of the base, and then we're going to take the area of the lateral surfaces. Now, what we saw when we broke down the pyramid is that the lateral surfaces can be found. Each triangle is 1/2 base times height, and here the base is going to be the perimeter of the entire pyramid. Now, like I said, we're going to see that in class tomorrow. So we're going to take the perimeter of the base, and we're going to take the height of the triangle. Now remember, it's not the height of the pyramid itself, which is straight down. It's the height of the triangle. That is something we call slant height. And so now when we're looking at the area of a pyramid, the total area of the pyramid, let's pull this up a little bit. We have the area of the base, we have the perimeter of the base, and we end up with this formula here. The area of the base plus 1/2 of the perimeter times the slant height. Now, the 1/2 here is important. It's only with the perimeter times slant height because we're using triangles, and the area formula for a triangle is 1/2 base times height. But go ahead and pause the video now and write down the surface area formula for a pyramid. Draw this image here along with this visual of slant height so we remember what slant height is and come back when we're ready to move on. So now let's look at an example problem of finding the area of a pyramid. So here, you can go ahead and pause the video if you want to and try to work through the formula. Otherwise, we're going to work through it here. The area of a pyramid is just the base plus 1/2 the perimeter times the slant height. Now here we're given the area of the base. The area of the base is 43 square centimeters. We're looking at plus 1/2. The perimeter of the base, we're not immediately given it, but each side of the base is 5 centimeters. And since this is a pentagonal pyramid with a base that has 1, 2, 3, 4, 5 sides, the perimeter will just be 5 times each side, 25 centimeters, and then the slant height, again, given from this dotted orange line that we have, is 14 centimeters. Now when we multiply all of these things together and add, we have 43 at the base, 1/2 times 14 is 7, and 7 times 25 is 175. 175 plus 43 is 218 centimeters squared. So that is the area for that particular pyramid, and this is the formula being outlined in yellow for the surface area of any pyramid that you might find. Now the same thing applies to a cone. Like we said, a cylinder was just a circular prism, but we really couldn't call it a circular prism because it has no faces, edges, and vertices. A cone is just like a circular pyramid. So we can look at the exact same kind of things. We can look at the area of the base, which is very familiar to us. But the question is, what about this curved surface? We can't really break it down like we did in the pyramid into its individual triangles. So we have to rely on the same idea that we had with the pyramids to be able to work through and find the area of this curved surface. A pyramid, just like a prism, has a slant height. And that's the distance from along the curved surface from the apex to the base. And so if we take the same idea that the area of the base plus 1/2 the perimeter times the slant height and substitute in the formulas that we know for a triangle, we can come up, or rather for a circle, we can come up with a formula for the surface area of a cone. Now the base is just pi r squared, only one base rather than two bases like in a cylinder. We have a 1/2. The perimeter of a circle is 2 times pi times the radius times the slant height, and now we can cancel out a 2 and a 1/2 to come up with the surface area formula for a cone, which is pi r squared plus pi rl. Again, remember the slant height, which is just the distance from the base along to the apex along the curved lateral surface, is the same idea as it is in a pyramid, and we need the radius. So for a cone, we don't even have to think about what's the shape of the base, how many triangles we have, etc. It's just pi r squared plus pi rl. Now let's see that in an example. Again, if you want to pause the video and try to work through it on your own and then come back, that is perfectly fine. Otherwise, if you want to see it in action, you can go ahead and keep looking through. If you haven't already, please pause the video and write down this formula along with this image down here so that you can see where L, R, and the surface area formula for a cone comes from. But now let's work through this one. This is area is pi r squared plus pi rl. Well, we have pi. R squared is 4 squared because that's the radius. And we have pi times r times L, which is 9. So this is our originally substituted formula there. If we're going through and finding the exact area, we have pi times 16 plus pi times 36. All of that together ends up with 52 times pi. So if we wanted to stop there and just give the exact area, it's 52 pi inches squared. But 52 times pi is not an easy thing to immediately understand exactly how big that is. So if we substitute in 3.14 for pi to find the approximate area, we end up with 163.28 square inches as the approximate area. So this one is exact, and this one is approximate. Depending on what we're looking for, either could be correct. So now we're going to go ahead and do 2 practice problems with pyramids and 2 practice problems with cones. So go ahead, pause the video, work through these 2 practice problems for the pyramids. This is a square pyramid here. We need that because we need to know the size of the base. This is a square. And the triangle for number 2, work through those, pause the video, and come back when you're ready to move on. So for number 1, we remember that our surface area formula for a pyramid is base plus 1/2 perimeter times slant height. Now the area of the base for this square is just the side of the base squared, so it's 8 squared, plus 1/2. The perimeter of the base is just going to be 8 times 4, because there are 4 sides, each of 8 centimeters long, which is 32, and the slant height is 12. 8 squared is 64. 1/2 of 12 is 6, and 6 times 32 is 192. 192 plus 64 is 256 square centimeters. 256 square centimeters is the surface area for the square pyramid. Now on number 2, we have a triangular pyramid, which is a little bit strange to see sometimes because you expect often, because of what you've seen in real life and in pictures, maybe with the pyramids in Egypt, you've seen lots of examples of square pyramids, but the triangular pyramids are also a type of that. So base plus 1/2 the perimeter times the slant height. Now for the base triangle, we know that the base is 6 inches and the height is 8 inches. So in order to find the area of that triangle, we do 1/2 base times height of the triangle, which is 1/2 times 6 times 8. Multiply all those together, and we end up with 24 as the area of the base. 1/2 the perimeter times the slant height, which is 1/2. The perimeter here is what we know with the size of the triangle. 6 plus 8 plus 10 is 24. And the slant height is 9. 1/2 of 24 is 12, and 12 times 9 is 108. So we have 24 times 108, 24 plus 108, and we have 132 square inches as our surface area for this pyramid. Now let's take a look at 2 cones. I'm going to ask you to find the exact surface area first, and then use the exact surface area to find the approximate surface area. So once we find the 2 parts of this, you're going to combine like terms using pi as a variable, and then use the 3.14 to find the approximate. So exact first and then approximate. Pause the video, work through these, and then come back when you're ready to move on. So for number 1, we remember that it's still base plus 1/2 perimeter times length, and when we substitute in the circle formulas, we have pi r squared, which is the area of that circle, plus 1/2 times 2 pi r, which is pi r times L. This is our surface area formula for a cone. Now, r is 2.5, so we have pi times 2.5 squared plus pi times 2.5 times 5.5. And when we go through with all of those calculations, we have 2.5 squared, which is 6.25 times pi. 2.5 times 5.5 is 13.75 times pi. And combining like terms, just as if pi was a variable, gives us 20 times pi. Now this is the exact surface area. And if we multiply 20 times 3.14, using the 3.14 approximate value for pi, we end up with an approximate surface area of 62.8 square inches. So that's for the first cone. For the second cone, we have 4 millimeters and 7.25 millimeters. Again, pi r squared plus pi rl. This is pi times 4 squared plus pi times 4 times 7.25. 4 squared is 16. 4 times 7.25 is 29. And we end up with an exact surface area of 45 pi square millimeters. But of course, like with the other things we've done with the cones, it is difficult to understand exactly what 45 pi means. So substitute 3.14 in for pi and get an approximate surface area of 141.3 square millimeters. So, to review, the surface area of a pyramid and a cone are related like they are to a prism and cylinder. The surface area of any pyramid is just the area of the base plus 1/2 the perimeter times the slant height, remembering the slant height is this distance and not the distance straight down. That is the true height of a pyramid. The slant height is along the lateral surfaces. And for any cone, the area of that cone is just pi r squared plus pi r